Okay, since this is our first use of a Phet simulator for the semester, I'm going to give you a little introduction to Phet and running simulations from there, and also I'll walk you through the simulation that we will be using for today's class. So first is Phet is given to us by colorado.edu, the University of Colorado at Boulder, and they're just absolutely fantastic. Um, uh, Heather Johnson and I donate part of our teaching money to them every time we teach because we just use their stuff so much. So I encourage you to support them in any way possible. But I wanted to point out signing in. So you can register. It's totally free. It's free to use. You don't have to register to use it. But if you register, I encourage you to click Teachers Register here and have either you, the student, register yourself as a teacher or have your parent, who's your homeschool teacher, register as a teacher. And there's extra curriculum and lesson plans and other support that's all free and visible for you when you register as a teacher. So I'm going to sign in. Okay, again, you don't have to sign in. Okay, and you won't have to search for what we're doing today because it'll be linked on our Haiku page. Okay, so there are different types of things on Phet. Some of them have this little Java symbol. This is like a cup of coffee. And some of them will have HTML5. HTML5 should just run in whatever browser you're using and you wouldn't have a problem. But some of the older ones that haven't been ported over are really still so good that we just need to use them. And they are going to cause you a little bit of a hassle with the Java. So first thing, if you click on it, it's going to ask you, do you want to keep it anyway? And you do want to keep it. Okay. And then I'm going to open it. And I get this error. So that is a Java helper file that is not working correctly. So go back and hit download. It should prompt us, do I want to keep this? I do want to keep this, but this time it's downloaded it as a .jar file, So go ahead and hit the download when you want to use an HTML thing like this. Okay, now when we click on this, I have a new computer. I haven't installed Java yet. When I click on it, it says, do you want to go to the Windows Store and look for an app to run this? I do not. Okay, so I'm going to click away. I'm going to click away from that. And instead, what I want you to do is you're going to go to, and I've already gone here, but I'm going to show you, just go to java.com. Okay, download, free Java download. That is what you want. So we're going to click on that. And again, with your parents' permission to install this, you will need administrator privileges. You're going to download and install Java. And it asks you, do you want it to make changes on the device? And you say yes, and click install. So this is not to help you program in Java. This is to help programs that were made in Java run on your machine. And then it kind of goes off into La La Land for a while. Wait for it to come back because it will come back. There it comes. Okay. I do not want to update my browser settings. There we go. And so you'll want, it's installing and downloading and doing various things. So you'll want to be on your home network, someplace that's fast to do this. Okay, we have successfully installed it. We can hit close, and it will want us to, you can verify. So we click that. It's going to check and says, congratulations. All right. So now let us go back to our downloads. And we want to go back to our .jar file and click on that. Double click on it. Okay, now it's starting up. Java is running it. Phet is starting it up. I'm going to accept and agree. I'm going to accept and continue with the software agreement. Okay. Now this part of the video is just about how we use this. This is about motion. This is about forces and motion. Okay, so we have two balanced forces here. One is the force due to gravity. So this box is being pulled towards the center of the earth with the force of gravity. It is not currently falling. It's not currently moving at all because the floor counters that force, and there is thus on this box there's a downward force due to gravity and there's an upward force due to the floor. Now they show the upward force drawn from the center of mass up. That's the same thing. You could draw the upward force here and the downward force coming down to the center of mass. They're the same thing, but this is just kind of convention. What you need to know is that there are two equal and opposite forces here. Anytime that an object is not accelerating. In class, we're going to talk about the difference between accelerating and velocity. Anytime that an object is not accelerating, all the forces on that object are balanced. Now, an object can be moving at a constant velocity and still have balanced forces. We will talk more about that in the next 3 weeks and probably for the whole year. Okay, so we can look at the sum of forces, which should be, oh, it's going to be 0. Okay. Now we're going to apply a force. And the force currently, if I apply this force, I have to apply enough force for it to overcome friction. Oh, I hope you didn't hear that. It's loud on my end. I think it does crash at the end, so it's a little bit loud. I can click those walls away, which is kind of nice. Okay, I'm going to stop it, and I'm going to clear, so it should return object. Okay, so it's back here. Okay, so I have a force due to friction, which is stopped, right? It's showing it as unbalanced. It shouldn't, because the sum of forces is, it should not, oh, I see, there is an applied force. Okay, so when there's 0 newtons, there was a little bit of applied force. When there's 0 newtons, it will just stay put. Okay? When I apply a force that overcomes the force due to gravity, now, the force of friction. So what I'm going to do is turn this into ice. Right now, this floor is wood, which means there's friction. In real ice, there's still some friction, but it's much less. But this is fictional physics perfect ice that has no friction. Okay, so I'm going to click no friction. Notice the box does not start moving yet, right? The box doesn't start moving because there's been no force applied to it and it was already at rest. And a body at rest tends to stay at rest unless acted upon by an outside force. That will be next week when we review Newton's laws of motion. But I'm going to act upon it with an outside force. Okay, so now it is moving. It is moving, and it's moving at a constant velocity. It's moving at a constant velocity because what I did was I applied a force and then I stopped applying a force. So my applied force is now back to 0 newtons. So it started moving and it's going to keep moving at a constant velocity. Notice that the forces are balanced. These are even. I can take this off and put the sum, and nothing shows up because the balance, the total of these is 0. Okay, let me return the object. I'll stop. Okay, now I'm going to keep applying a force. When I continue to apply a force, Newton said force is proportional to mass times acceleration. Eventually that was turned into equal. So, so a force is equal to the mass times acceleration. So as long as I'm applying a force, my object is accelerating. That means its velocity is changing. In this case, it's going to continue to speed up. Okay, so let me apply a force. It's getting faster, 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 faster. Okay, so as long as I continue to apply a force, it's going to accelerate. In this case, that means get going faster in the direction that we were pushing. Velocity is any change in speed or direction. I'm sorry, acceleration. Oh, very important. Acceleration is any change in velocity. Velocity is the speed you're going and the direction. So you can change you can accelerate something by changing just the direction, or you can accelerate something by changing just the speed, but accelerate, or either any combination of those. Acceleration is any change in velocity. Velocity is speed with a direction. Okay, so that is there are some more fun things over here. So you can do force graphs, and this is mostly to show you about overcoming friction, which is pretty fun. So we can, let's see. And you can choose different objects. There's a sleeping dog. Oh, I hadn't seen that one. And you can do ice. You can, okay. And you can, with this one, you just apply it with your fingers. Okay. And you can make it crash. It's quite nice. The robot moving company, you it includes energy. We're not going to talk about energy yet. So really, the thing that I was most interested in was doing the ice, getting you to understand that force is equal to mass times acceleration. Anytime you apply a force, you're going to change velocity. Acceleration is any change in velocity, and that includes direction or magnitude. Okay, there will be a couple of other simulations, but good luck. Have fun.